Hello everyone. Previously, we discussed about the CO of Eratosthenes algorithm. Also, we implemented that one in the code, right? So, using JavaScript. So, today, what we'll be doing, we will be discussing Knuth-Morris-Pratt algorithm, also known as KMP algorithm, right? So, basically, what we'll be doing, let's discuss the approach first, and then we'll try to implement that in the code. And finally, we'll discuss the example along with finally after the example we'll be discussing the time complexity and the space complexity, right? So initially, just give me a second. Initially, what we'll do, why we'll be making use of the KMP algorithm. So here, just give me a second. Yeah, KMP algorithm is used because we can efficiently search for the occurrences of the pattern within a text, right? By utilizing the pre-processing step to create the longest prefix suffix, nothing but the LPS array. So why we are making use of the LPS array? Because this LPS array, longest prefix suffix array, will help us to skip the unnecessary comparisons in the text when a mismatch occurs. So this will be very helpful. So basically, it allows the algorithm to achieve the linear time complexity, right? So the main function KMP here that we'll be using will iterate through the text and it will compare it with the pattern. Basically, it will be iterating through the text and it will be comparing it with the particular pattern, while the compute LPS array function constructs the LPS array for the particular pattern that we'll be making use of in the code. So let's write the code. Let's try to understand, and then we'll discuss this one with the example, as well as also finally we'll discuss the time complexity and the space complexity. So initially, let me remove this one. Function KMP. So here I'll take two parameters. One is text and another one is pattern. So here what we will do, first we have to compute the LPS array, nothing but the longest prefix suffix array, as we had discussed in the approach. First, let's compute the LPS array for the pattern. So let me initialize this one, LPS, this one too. We have not written the compute LPS array yet, right, for the pattern. So I'll just leave space over here. First, let's write the this one, function compute LPS array. So I'll come here. Let's write this one first. Function compute LPS array, right? So within this one, let me consider the parameter pattern. So here what we'll do, let's initialize the LPS array initially with zeros. So I'll just give here LPS equals new array of size, the length of the pattern, whatever the pattern that we get. So the length of the pattern, here I'll just give length, and let's fill this one with zeros initially. Next step is we'll initialize the length of the previous longest prefix suffix. So I'll just give here initialize the length to 0. Next, let me give I equals 1. Nothing but we are starting from the second character of the pattern. So we'll be ignoring the first character and we'll be starting from the second character of the pattern, right? So first step is we have to build the LPS array. Let's see how can we build the LPS array. Here I can write I less than, if I is less than the length of the pattern, then if character matches, then we will update the LPS array. So here is pattern matches, means if iterated value of the pattern, if it is equal to length of the pattern, right? So pattern of length, then we will increase the length of the current longest prefix suffix. Also, we will set the LPS value for the current index. Finally, we will move to the next character in the pattern. So I can write in this way. Let's increment the length. Then iterated value of the LPS or LPS of I, this will be equal to the length. Then finally we have to move to the next character in the pattern, right? So let's increment the I. So I hope this is clear till here. So next step is, if there is a mismatch in the pattern, so I can write in this way. If consider length I have considered, right? If length is not equal to 0, then if there is a mismatch, then we have to use the LPS array to backtrack from the beginning. So nothing but we'll be making use of the backtrack over here. Here length, I can just give this one to LPS of length minus 1, the last one. So again, we have to backtrack from beginning. So else I can just set the LPS value to the 0 if no prefix suffix exists. So if there is no prefix suffix exist at all, if it doesn't exist, then we can just set the LPS value to the 0. I can write in this way. LPS of I, or the iterated value of the LPS, this one will set this one to 0. Also, we have to move to the next character in the pattern again. So I'll just give I++. So I hope this is clear. So finally, what we will do, we have to return the LPS, right? So here we have to return the computed LPS array. So let me consider this one, return LPS. So I hope this is clear. Next, let me come here. So here, what we were doing here, so we have to compute the LPS array for the pattern, right? So I can consider now, I have this one, compute LPS array with me. So here I can just directly consider the recursive function compute LPS array, and for the pattern, let me consider pattern over here. After doing this, let's initialize the index for the text. Also, let's initialize the index for the pattern, text and as well as the pattern. Let's initialize this one, I equals 0 and j equals 0. So finally, after the initialization part, as usual, we'll be going through the iteration. Nothing but we will loop through the text to find the pattern. So the I has to be less than the length of the text, right? So I can write in this way. It has to be text.length. If I is less than length of the text, then if the characters match, we will move to the next character in both text as well as the pattern. If text of I, if it is equal to pattern, say if the character matches, if the character match, then we will move to the next character in both text and pattern, right? So I can just increment this one, I text as well as the pattern, this one. Then next step, what we can do, this will be the last step. Basically, if the entire pattern is found in the particular text itself, then let's see what we will do. If it is equal to length of the pattern, then we will return the starting index of the found pattern in the text. So we can return in this format, I minus j. So else if I less than length of the text and iterated value of the text, if it is not equal to pattern j, then if there is a mismatch after some matches, then we will be using the LPS array to skip the characters in that particular pattern. And finally, we will move to the next character after all this one, after performing all the things. So how can I write if there is mismatch after some matches? So we can write in this way, right? If j not equal to 0, then we will use the LPS array to skip the characters in the particular pattern. I can just write here LPS of j minus 1. Finally, we have to move to the next character in the text. So I can just write here else. Just give me a second here. I made some mistake, I think. I don't know. I plus plus. So here, I hope this is clear. So finally, if the pattern is not found, then we will return -1 here, right? So if there is no pattern, if the pattern is not found, then let's return -1, indicating that this is failure to search the pattern, right? So I hope this is clear. So next, I hope this works. Next, let's try this one with the example, right? I'll just give here const. Let's consider some random text. So AB, ABC. I'll just consider ABA, then BC, ABC. Here, then finally ABC. So let me consider this text, and also let me consider the pattern. So what pattern we have to search for? This one, let's go with ABC, ABC. So first one here, this one is the text in which the search, the text in which to search for the particular pattern, and also this is the pattern that we have to search it, the pattern that we are searching for, or the pattern to search for. Finally, we will call the KMP function with the text and pattern. So I'll just take this one as a result, and I'll give KMP of text comma pattern. So this is fine. The final step is we will output the result. Nothing but we will we have to get the pattern and at what index it is found. I'll just write in this way to print. I'll just make use of the console log here. Let me consider backticks, and let me make use of the string interpolation. Pattern found at index. And let me make use of this one. Here within this one, let me give a result. So result I have considered, right? Yeah, this is fine. So yeah, this is fine. So we have to get pattern found at this one. Just give me a second. Here, right? So we have to get this one at the index 8. So let's check whether this works or not. We are checking for the pattern ABC, ABC. So we have to get 8, index 8. Let's check this one. Let me run the code. We are getting this one at the index 7, right? Somewhere we have done wrong here. So just give me a second. So here what I have done here is in the line number this 125, I have misspelled this one actually. This has to be length, right? So let me remove this one, and this has to be length. So this works absolutely correct. We are getting the pattern found at index 7. This one index is 0 based, right? So it will start from 0. So we have found this one at the index 7. Basically we have to get 8 length. So according to the length we have to get 8, but we are getting the pattern found at index 7. So this works absolutely correct. You can check this one. You can dry run the code and check with different examples as well. So this algorithm works absolutely correct. So this is it. Thanks for watching, guys.